Lesson 7, factoring trinomials. So factoring trinomials means you're going to go from a trinomial into two separate binomials. So it's kind of the opposite of multiplying the polynomials. So what you're going to do is, if you look at this, all this means is you have a number beside x squared, a number beside x, followed by a number. And you want to find two numbers that add up to this b and multiply to get a times c. So what we're going to do right now is trinomials that a is equal to 1. So for our first example, our a equals 1, b equals 10, and c equals 24. So we want two numbers that add up to 10 and multiply together to get a times c, which is 1 times 24, which is 24. So a quick way to figure this out is to go through your factors of 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. So we want two numbers, when you add them together, you'll get 10. So 4 and 6 make 10. So 4 plus 6 equals 10, and 4 times 6 equals 24. So if you get this to work and this to work, you found your two numbers. And when a is 1, the last step in factoring is you're going to put two brackets. You're going to put an x in each of them, and then you're going to put your number behind it. So positive 4 and positive 6. And that is your factored trinomial. And a way to verify that you've done it right is if you take x plus 4 and x plus 6, if you multiply it out, you should get back to where you started. So x times x is x squared, x times 6 is 6x, 4 times x is 4x, and 4 times 6 is 24. Combine our like terms, and we get x squared. 6 plus 4 is 10, and plus 24. So this is equal to our original, so we know we did it right, so this is our answer. That is how you factor a trinomial. And this is the most important thing that you need for your following math classes, because it comes up a lot. So for our next example, we have a equals 1, b equals 7, and c equals 10. So we want two numbers that add up to b, which is 7, and multiply to get a times c, which is 1 times 10, so 10. So we're going to go through our factors. So we have 1 times 10, 2 times 5, and that's it. So 5 plus 2 is 7. And 5 times 2 is 10, and because x squared has a 1 in front of it, we go x plus 5, x plus 2, and that is factored. And to verify, we multiply it out. So x times x is x squared plus 2x plus 5x plus 10. Combine our like terms. We have x squared. 5 plus 2 is 7x plus 10. So this worked. So this is our factored polynomial. Next example, we have a equals 1, b equals negative 7, and c equals negative 60. So you want two numbers that add up to make negative 7 and multiply to get 1 times negative 60, so negative 60. So we're going to go through our factors of negative 60. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. So we need two numbers that when you add them together, it'll make negative 7. Now, because this number is negative 60, to make that work, one of these has to be a negative and one of them has to be a positive. because a negative and a positive make negative 60. So we want two numbers that when you subtract them, you'll get 7. And 12 minus 5 is 7. And because our negative 7 is the bigger number, we want negative 12 plus 5. Negative 12 times positive 5. So when you get those two numbers to work for both of them, and a is 1, you put them into your brackets. So we have x minus 12 and x plus 5. To verify, we multiply it out. So we have x times x, which is x squared, plus 5x minus 12x minus 60. X squared, combine the like terms. Negative 5 minus 12 is negative 7x minus 60. This works, so we factored it properly. For the next example, we have a equals 1, b equals 9, and c equals negative 36. So we want to find two numbers that add up to 9 and multiply to get negative 36. So we're going to go through our multiples. So we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And because this is a negative, we want one positive and one negative. So what numbers can you take that you subtract them to get 9? So if you take 12 minus 3, you would get 9. And because 12 is our bigger number and our answer is positive, we want positive 12, subtract 3. Positive 12, subtract 3. Since a is 1, we put it into our brackets as x plus 12 and x minus 3. And if you were to check this, you would expand out the brackets and distribute your variables, and it does in fact work. You don't have to verify all of your answers, but it is good practice to do that to make sure that you did it right. For the next example, our a is 1, b is negative 14, and c is 45. We want two numbers that add up to negative 14 and multiply to get positive 45. We have 1 times 45, 3 times 15, and 5 times 9. Now, because this is a positive and this is a negative, we know that our answers have to be both negatives, because a negative and a negative make a positive. So if you take 9 and add 5, you get 14. So negative 9 plus negative 5 is negative 14. So there are our two numbers. It works for both. So we have x subtract 9 and x subtract 5. And this is our factored polynomial. For the last example, we have a equals 1, b equals negative 8, and c equals 15. So we want two numbers that add up to b, which is negative 8, and multiply to get 15. 1 times 15, and 3 times 5. Because this is positive and this is negative, we know that both of our numbers will have to be negative, and negative 5 plus negative 3 will make negative 8. So this works. So we put it into our brackets as x minus 5 and x minus 3. So this is our factored polynomial.